Okay, thank you. It's a pleasure to be here. Thank you. So I'm going to talk about a significant improvement to cell injection systems that is actually going to enable the high throughput of cell injections. We are a team of three. I'm an OBGYN, REI fellow, a neuroscientist, and the product inventor. Dr. Gao is in electrophysiology, and Dr. Seli is a fertility specialist. So the problem starts here. We have three great-looking eggs in the world of IVF. There is a problem. One of them is dead. And unfortunately, through light microscopy, we will not be able to tell which one is the dead one. We need a better way to assess cell viability, and even more than that. This is a video that you are more than welcome to see in our e-poster. It's a long one. Here we struggle penetrating a cell. It's not that easy even penetrating a cell when we do IVF. We cannot confirm cell penetration, always. So this is our product. 2 adapters and a meter. And this is what we do. We measure electrical resistance in real time. The resistance outside the cell is about 32 mega ohms. And when we penetrate the cell, the resistance goes up to 40, 41 mega ohms. When we retract the pipette, the resistance goes back to baseline. So actually, we confirm 2 things: true cell penetration and that the cell is viable. Cells that are dead will not show resistance increase. So this is one of our experiments on human eggs. In the world of electrophysiology, we know that penetrating healthy eggs will show high resistance. This is what we see on the left. But the question is, what happens with the non-viable ones, the bad-looking ones? Would we get any false positive results there? And as you can see, there are no false positive results when we deal with non-viable eggs. And this is very important for automated cell injection systems. So what we offer is real-time confirmation of cell penetration and viability, independent of visualization. We confirm viability and we don't damage the cell. This is first-in-class, fully functional device that can be integrated into any cell injection system for just $100. So current manual and automated cell injection systems rely on image processing algorithms and pressure sensing techniques. Sometimes both of them are unreliable. And studies show that if we rely on image input alone, the error rate can range between 30 to 50%. So actually, we can integrate our device into these systems and improve them. We can increase success rates in IVF and in general, and we can speed up the process, actually allowing the commercialization of high throughput systems. So the markets are large, and our device is already fully functional. We can integrate it into the IVF market immediately, and to the glass pipettes market, a $1.4 billion market. Later on, we plan the integration of our device into automated systems in the IVF world and in general. Cell therapies, for example, $20 billion. I'm sorry. So the target customers are industry, pharma companies, manufacturers that make cell micromanipulation systems, manufacturers that make proteins, genetic materials, fertility clinics, research institutions, and medical centers. Our immediate plan is to improve success rates. We can integrate our device into existing systems in order to improve training, reduce their cost. We don't need FDA approval for that, and we need $200,000 for product manufacturing and distribution.
1 minute.
Later on, we plan the integration of our device into automated systems, and these are the systems that are the real high-throughput systems, and opening the door to high-throughput cell injections. Thank you.
Thank you. Turn to our judges.
Can you just talk a little more about your IP and what is protected or protectable?
Sure. So we submitted the IP with the Yale OCR. We are protecting the method. As you can tell, it's very simple. This is our protection, the IP, which is very broad. And We can discuss it later, or I can show you the claims.
Do you have any other questions?
Yeah, is there anything similar to this or any clinical evidence that's close that's been published or talked about?
So we've done an extensive search with Yale OCR. No, nothing has been done. This is application of simple electrophysiology principles into our field, cell injection and IVF. It has never been done. It has never been checked. So this is a first-in-class device. And by the way, this is how it works. This is an adapter that is integrated into an existing system. It allows the integration of electrical wire into a pipette, and then we can measure whatever we want through with electrophysiological equipment, very simple equipment. The product is very cheap.
Any remaining questions?
Have you talked to any of the competitors, the industry players you put up there?
We're very young. Not yet. That's what we are going to do. And we just published we submitted to publication our first paper.
Okay, great, thank you.
And without any further ado, the #1 team on the tech side, Acis, ACIS, led by Amir.mor.